in order to solve this question, we need to know a formula. It's integration from a to b, fx dx plus or minus integration from a to b, gx dx should equals to integration from a to b, combine them together, fx plus or minus gx bracket dx. So according to this formula, the original function, the left side of the original function could be from 0 to pi over 4, combine them. So tangent x to the power of n plus tangent x to the power of n minus 2 bracket dx together. But look at these two terms. They have something in common, right? We need to take common factor out because the first term equals to tangent x to the power of n minus 2 times tangent x to the power of 2. This is based on a to the power of m times a to the power of n equals to a to the power of m plus n. So this is actually tangent x to the power of n minus 2 plus 2. So it is tangent x to the power of n. Okay, so we know that tangent x to the power of n equals to this. So the first term and the second term, they have something in common. They have tangent x to the power of n minus 2 in common. We need to take a common factor out. So it will be 0 pi over 4. We take a common factor out. It will be tangent x to the power of n minus 2. This is a common factor. Times, we take this out of tangent x to the power of n. We still have tangent x to the power of 2. And then plus 1 bracket dx. Okay, we learned from trigonometry that the tangent x to the power of 2 plus 1 equals to secant x squared. So the function will be integration from 0 to pi over 4 bracket tangent x to the power of n minus 2 times sec x squared. Okay, until now, we have a product of two functions. Tangent x to the power of n minus 2 is a function. Secant x to the power of 2 is also another function. And they are multiplying together. We never learned how to integrate multiplying two functions. So there's only one exception. We learned integration by substitution. But how to use integration by substitution in this case? Integration by substitution is when you integrate a function u and then you have du dash, so basically u dash dx. It is the same as integration by u du, because u dash is du over dx. This is du over dx. It's the same thing. So dx cancel out. It will be integration of du du. Okay. So which one should we make tangent x equal to u or secant x equals to u? It will depend on the derivatives. The derivative of tangent x equals to secant squared x, this one. But the derivative of secant x will equals to secant x times tangent x. So it's better that we let u equals to tangent x, and then du over dx will equals to exactly secant squared x. We don't need to add or subtract anything. This is exactly du over dx. So the original function will be 4, 0, and u to the power of n minus 2 times du over dx bracket dx. So it will equals to integration from 0 to pi over 4 u to the power of n minus 2 du. Okay, that's easier. Then it will be u to the power of n minus 2 will be u to the power of n minus 2 plus 1. So u to the power of n minus 1 divided by n minus 1, new exponent, and then we need to replace pi over 4 minus 0. Okay, and that will equals to because 1 over n minus 1, this part, times is a constant term. It's a constant number. So the original function could be 1 over n minus 1, because constant number doesn't influence the integration part. So you can just replace u with tangent x again. So tangent x bracket to the power tangent x to the power of n minus 1, and then pi over 4 and 0. So equals to 1 over n minus 1. Okay, then replace x with pi over 4. So tangent pi over 4 bracket to the power of n minus 1 minus replace tangent with x with 0. So n minus 1 bracket. Okay, we already know that tangent pi over 4 equals to sine pi over 4 divided by cosine pi over 4 equals to 1. So 1 to the power of anything still equals to 1. Tangent 0 is 0. 0 to the power of anything still equals to 0. So we have proved that the left side equals to the right side. That's the end.